those are the what's going to carry our electric charge from her body into these wires right here. Then what we're going to do is we're going to listen as I plug her into an amplifier. So this is like many things in science, you have to make it bigger, right? You know, telescopes, like I said, make distant planets bigger. You know, microscopes make small cells bigger. You know, PCR machines make DNA bigger, but this makes small amounts of electricity bigger. So when I plug it in and we listen to it, so go ahead and give your hand a squeeze. And relax. Do it again. So those are the action potential. Those are the spikes that are coming from your cortex down to your spinal cord and back out to your arm. So what is your name? Annabella. So Annabella, I'm going to show you really quickly what your brain looks like. Okay. So you're on the screen, so give it a squeeze again. Okay, so those are the spikes, and so I'm going to show you what an individual spike looks like, so we can see what the action potential looks like. I'm going to pause it here, just relax again, and then I'm going to average it a few times. So go ahead. So this is like a little trigger. I'm going to squeeze it again, and then we're going to zoom in on this guy. Oh yeah, look at that. There it is. So this is the action potential. These are the neurons. This is how the way, like everything that the first kiss, the smell of your grandmother's closet, all of those memories are being encoded by this. It's like in the movie The Matrix, when you saw that code, like, oh my God, that's reality. This is your reality, people. This is how the spikes are actually being communicated. So we're going to use this right now to do an experiment. I'm going to do one quick experiment. And then I'm going to invite somebody else up to help us as well. Turn this down for a second. So what the experiment is now, so if you guys can see here, whoopsie. All right, can you all see that screen? So it's 1 second right here. I want everyone to look at this. It's 1 second of time. And I'm going to play a little game here. And I'm going to show you a little light, okay? And when you see that light, I want you to answer. I want you to tell me that you see it by like squeezing as fast as you can. This. You do it. Okay. So that's going to be the answer. And the question is, how fast can you react when you see this light come on? Okay. All right. What do you guys think? Let me pause that one. Come back. So, oopsies. This is 1 second. So that's about 150 milliseconds, I would say. All right. And so what we're going to be able to do now is just from her wrist, or just from her arm, we're going to be able to clock the inner workings of her brain, all right? And I'm going to do that by doing another experiment where you're going to see the red light and you're going to move your arm, okay? Just what you did last time was perfect. And I'm going to, when you see that red light, you're going to move. So now I've added a distractor, all right? So this is, so you're going to ignore the green one and only, so what's going to happen inside of her brain when she does this now? She now has to make another decision. She's making a decision on what color this is, and then she's going to react. But everything else is the same. She's going to see a red light, and she's going to move. And so what we can do is I can do it a few times. Infinite reaction time. All right. So I'll do it a few times. Are you? Yeah. Well, actually, no. We've now changed this because it turns out that 50% of the population are colorblind to green and red, and okay. So we've now switched it to blue and red. All right, but so bear with me. Okay. So now we see a longer delay because now she has to make a decision. So I'll show you really quickly what that looks like. So 150 milliseconds is just to make a quick change, but when you have to make that decision, there's another gap there. And what we can do is we can subtract the two reaction times from each other, and now we know exactly how long it takes for Annabella to make a decision in her brain, at least a decision about color.